Today's lesson deals with two special right triangles. There are two special right triangles that we're going to talk about today. So I'm going to do this on a blank page real quick. I want you to draw these two shapes. They're going to be two different triangles that we're going to talk about. This first triangle is a 45, 45, 90 triangle. The key thing you should know about it is that it has two legs that are the same length. So if this one's x units long, this one's also going to be x units long. It also has a hypotenuse out here, and this hypotenuse will be longer than the legs. On a 45, 45, 90 triangle, there's a special formula that we can use. The formula is hypotenuse equals the leg times radical 2. We're going to use this formula anytime we see a 45, 45, 90 triangle. The other special type of triangle is a 30, 60, 90 triangle. 30, 60, 90 has two formulas and it has different words along the sides. These are both the legs, but they are different sizes. So we're going to call this one the short leg, and this one we're going to call the long leg. Obviously, this one is longer than this one, or this one is shorter than that one. That's how they get their names. They're both legs, one's long, one's short. The other piece is a hypotenuse. On this one, we have our different formulas, and here they are. Hypotenuse equals 2 times the short leg. The other one is long leg equals short leg times the square root of 3. Now that we know these formulas, we can go back and we can focus on some of these examples. So let's look at example 1. It says find the length of the hypotenuse. First off, you need to be able to look at this triangle and determine, is it a special right triangle? Well, I see a 45 and a 90, but how big is that one? Okay, so the key thing we should realize is that these two add up to 135. All the angles should add up to 180. 180 minus 135 will give us another 45 here. So we could prove that that's a 45, 45, 90 triangle. If you know for sure it's a special triangle, you can then use our formula. Once again, the formula was hypotenuse equals leg times radical 2. So what do we know in this formula from the picture? We know our, what's that piece? What's the 6 on there? It is a hypotenuse or a leg? It's a leg. So I'm going to plug that number in for leg. So our hypotenuse equals 6 times square root of 2. The good thing about this is you are done. We are done because that radical underneath, that number right there, will not simplify. There are no perfect squares that divide into 2, so that radical will not simplify. You don't need a decimal answer because it's not asking you for one. And this is actually more accurate than a rounded decimal answer. That's why you're done. On the next picture, we have another triangle. Is it a special right triangle is what you should be thinking. Do you think it is or not? Okay, it seems like it is. So I see a 90 and I see its isosceles. Anytime you know it's 90 and isosceles, it will be a 45, 45, 90. Now we can use our little theorem. Our theorem, once again, our formula says hypotenuse equals leg times the square root of 2. We know that our leg this time is different. It is 4 times the square root of 2. But then we have another square root of 2 in our formula. So now we got to do a little bit of algebra. What you should remember is anytime you have a radical term times itself, you get the number underneath. So radical 2 times radical 2 is the same thing as saying radical 2 squared. Anytime you square a radical, it just cancel out each other. You're left with a number underneath. So right now, 4 times 2 is 8. The hypotenuse is 8 units long. Up next, we have example 2. Example 2 seems to look like another special right triangle. It seems to look like a 45, 45, 90. I know it's a 45, 45, 90 because the legs are the same and it's a 90-degree angle. Since we know it's a 45, 45, 90, we can use our formula. Once again, it's hypotenuse equals leg times the square root of 2. Now in this case, what piece do you know? Hypotenuse, so we can plug in for hypotenuse. That's 9 square root of 2 in for the hypotenuse. And we'll call our leg x since that's how it's labeled on the picture. Now, you've done this kind of problem before. You've solved from here. What is the x doing with this term? It's multiplying. And how do you get rid of multiplying? You divide. That way they'll cancel. But notice over here, when you divide by that, what happens to these radical terms? They cancel, and you're left with the number 9. X has a length of 9. What I want you to do now is go down and try these 2 checkpoints out. I'll pull it up on the screen so you can see it a little bit better. Try these 2 checkpoints. They align with examples 1 and 2. On these pictures, once again, you need to remember, are these triangles special? So this one right here, is it special? 45, 90, I can solve for that one fine. It's another 45. So yes, that one I can prove is a special triangle. From there, I got to remember on my special triangles, I have a formula. Hypotenuse equals leg times square root of 2. I don't know my hypotenuse. It is x. My leg is 2 radical 2, and then there's another radical over there. We talked about this a second ago. First off, you need to bring down that 2. But these kind of combine. Radical 2 times radical 2 is just a plain old 2. 2 times 2 is 4. There's your answer on that one. On this one over here, similar process. Hypotenuse equals leg times radical 2. So this time our hypotenuse is given. So we'll plug that in. Our leg is x. And we've seen a problem just like this earlier. X is multiplying by this term, and to get rid of multiplying, you need to divide. Divide by that radical 2 to get it to cancel. And notice, when you do that over here, they cancel again. You're left with x is 12. Example 3 says you make a guitar pick that resembles an equilateral triangle with side lengths of 32 millimeters. What's the approximate height of the pick? First thing you need to remember is it's not going to give you this section that's down here in the solution. It's only going to give you this little paragraph up here, and you got to remember traits about equilateral triangles. So I want to remind you of this real quick. An equilateral triangle looks something like this. What should you know about an equilateral triangle? Equal angles and equal sides. Well, we know the angles are equal, but what are their measurements? They are all 60s. Please write this down so you remember this fact. These are all 60-degree angles. Equilateral, equiangular. Those angles are all 60s. So what you'd have to realize is you start here, but they want the height. And remember, the height is another word for altitude. And an altitude basically splits this triangle into 2 equal parts. And you can see that better illustrated over here. When you draw this height here, you've created this little triangle, and you've taken that 32 and cut it into 2 16-millimeter pieces. So we're only needing to focus on the 32, the h, and this 16. Now this triangle is not a 45, 45, 90, so we have to try the other formulas. The 2 formulas, once again, are hypotenuse equals 2 times the short leg, and long leg equals the short leg times the square root of 3. So these are different formulas. You got to be able to substitute in the proper numbers. That h is what part on the triangle? It's the long leg. If you notice, the long leg is not even in this first formula, so you got to plug it in the second formula. Go ahead and try that real quick. All right, so here's what you should realize. H is our long leg, so it plugs in for that. Short leg is down here at 16. The only thing that we need to think about is that answer appropriate for this type of question? Because if I told you the height of something is 16 times radical 3, you probably wouldn't have a good idea of what I'm talking about. So in real life problems, it's okay to round that answer. So try that real quick. 16 times the radical 3, and tell me what you get. I think it's 27. 27.713. Okay, and units are important. Millimeters. The long leg is the H, so it's kind of deceiving. H does not stand for hypotenuse. In this case, it stands for the height. So it's kind of confusing. Be careful there. Good work. Example 4 is a little bit different. It says find the values of x and y. Write your answer in simplest radical form. What I want you to remember is that you have two formulas. We have two formulas on this one. We have hypotenuse equals 2 times short leg. And then we have another one. It's long leg equals short leg times the radical 3. First off, let's look over here. Can we plug in anything for long leg? You could plug in 8. Can we plug anything for short leg? X. All right. And there's the radical 3. Let's look over at this one now. Can we plug in anything for hypotenuse? Y. Can we plug in anything for short leg? Our short leg is going to be X. Can you solve over here? No. So this should show you that you can't really do much with this formula. We've got to be focusing on this one over here. First thing we should do is realize, how do you get rid of the radical term? Divide by it. They cancel here, but does it cancel on the left side this time? No, it does not cancel this time. So that's a problem right there. You got to realize that this key fact, and write this down somewhere important. Just write the fact that no radicals on the denominator. The denominator is the bottom. This is a key fact that you have to know. You cannot leave radicals on the bottom, so we got to simplify that. So the key thing is how to deal with this piece right here. So I'm going to teach you a little trick. And this kind of stuff they expect you to be able to do in Algebra 2. To get rid of the radical on the bottom, we multiply something called the conjugate. This is the conjugate. So basically, you multiply by itself over itself. You're going to see a lot of radical 3's now. So you multiply by what you're trying to get rid of over itself. Now, this is not hard to simplify because we learned how to deal with this earlier. Radical 3 times radical 3 is just 3. And the top is done. We're done with that problem. The 8 over 3 does not simplify as a fraction, so that problem is completely simplified. That means we have now solved for x. So our x is 8 radical 3 over 3. Over here now, we have to plug it in to solve for our other variable. We got to solve for y in this case. So I'm going to say y equals 2 times that term that we just found, 8 radical 3 over 3. We got to be able to simplify this. Does anybody have a guess at how to simplify that? There's no opposite reciprocal really needed. All you do is 2 times 8. What's 2 times 8? And double check. Does 16 over 3 simplify? Done with that one as well. On this next one, it gives another real-life problem. This time, we're just going to focus on the picture to save a little bit of time. So the picture looks like this. We're given a 60. We're given a 24. So the goal is to figure out this piece right here. We'll call it X. We're trying to figure out that height. Basically, you're trying to figure out how high the tip of this windshield wiper is from that part on the car. We're trying to figure out that piece. So what kind of triangle is this? 30, 60, 90. It's a 30, 60, 90 special right triangle. It has two formulas. Those two formulas are hypotenuse equals 2 times short leg. The other one is long leg equals short leg times radical 3. We got to figure out which one to use. First off, this is our hypotenuse, and this is our long leg. Do we have a formula that relates long leg and hypotenuse? Nope. No. So neither of those can give us our answer right off the bat. That means we're going to have to use two separate formulas. So it doesn't matter which one you pick first. This top one's actually really nice and easy. So hypotenuse we just found is 24. So I can plug in 24 here. We have a 2 times the short leg. Can I solve for the short leg pretty easily? Yeah. Divide by 2 on each side. So short leg is going to be how big? 12. That one's very easy to simplify. The long leg one's a little bit different. Might not be that hard though. Take the short leg, plug in. Our long leg is X, so I'll plug that in first. Our short leg is 12. But once again, think, does the answer make sense for that type of problem? If I told you the windshield wiper was 12 radical 3 high, no, it wouldn't make sense. So this is where you could give a rounded answer, and that would be appropriate. So type that in real quick. 20, something like that maybe? 20.785, and units are appropriate on real-life problems. It's in inches. There's the answer on that one. Now try these 3 checkpoints at the bottom, see how you can do. All right, here we go. On number 3, you should realize it's a 30, 60, 90. We have 2 formulas for those. Right now, we are given our long leg to solve for, and we have our short leg. Is there a formula that relates short leg and long leg on 30, 60, 90? Yes. The formula is long leg equals short leg radical 3. So all you got to do is plug in what you know. This piece is the short leg, so I'm going to plug it in there. 2 radical 3, and then there's another radical 3 to pull down. So once again, we're solving for x, which is the long leg. This side simplifies nicely. Radical 3 times radical 3 is just a 3. So bring down the 2. So really just saying 2 times 3. 2 times 3 is 6. Final answer is 6. Number 4. This one took an equilateral triangle, a 12, 12, and 6 plus 6 is 12, and cut it in half. So now we can just focus on half of the picture. On this one, you got to be able to solve for this long leg. So long leg, and you're given short leg and hypotenuse. So I would definitely be using this formula. Long leg equals short leg radical 3. The long leg is h. The short leg is 6. 6 radical 3 is your answer. Done. You don't need to give me a decimal there because it's not a real-life problem and because this is more accurate than a rounded answer. The last one deals with a windshield wiper. So it's saying earlier you had this picture where the 60 was right here, and here was our 24-inch windshield wiper. But now it's saying change the picture a little bit. Now it's saying your windshield wiper has a 30-degree angle down here, and you're trying to figure out the height this time. So remember, this is our short leg. This is our hypotenuse. Is there a formula that relates short leg and hypotenuse? Yeah. Definitely. The formula is hypotenuse equals short leg times 2. Actually, it's 2 times short leg. So hypotenuse would be 24. 2 times the short leg is easy to solve for. You divide by 2. You get the short leg is 12. And the units are in inches. There's your final answer.